So here in the weighted graph class, let's add a new public method, public boolean has cycle. Here we need to iterate over all the nodes in this graph and start a depth first search from that node. So for each node, in nodes.values, now here we need a recursive method for our depth first search. So private boolean has cycle. We need a node here. We also need the parent of that node, as well as the set of visited nodes. Let me put it on a new line. So set of node called visited. Now let's focus on the private method first. So in this method, first we need to add this node to the visited set. Then we need to look at all the neighbors of this node. So for each edge, in node.getEdges. Now if this neighbor is where we came from, we're going to ignore that. We're going to get another neighbor. So if edge.to equals the parent, that means this is where we came from. We're going to continue and look at another neighbor. Otherwise, if this neighbor we're going to visit exists in the visited set, that means we have a cycle, so we should return true. So if visited contains edge.to, then we're going to return true immediately. There is no need to look at the other neighbors. Otherwise, if we haven't visited this neighbor, now we should recursively visit that neighbor. So we call the hasCycle method, give it this neighbor. Now as the parent, we're going to pass the current node. That is the node that we have over here. So we pass these two node objects, as well as the set of visited nodes. Now this will return a Boolean value. If we find a cycle, we'll return true immediately. There is no need to look at the other neighbors. Now we can improve this code, as I showed you in the last section. We don't really need this local variable. We can put this expression in our if statement. That is better. We can also combine these two if statements. So if you have previously visited this node, or there is a cycle in this node, then we're going to return true. Okay? Otherwise, we'll look at another neighbor. Once we have visited all the neighbors, that means we didn't find a cycle, so we should return false from this method. So here's our private recursive method. Now back to our public method. Here we need to create a set of nodes. So a set of node, we call it visited, and set it to a new hash set. Now for each node in this graph, if you haven't seen this node before, so if visited doesn't contain this node, then we're going to start our depth first search from this node. So we call our private recursive method, pass this node as the first argument. Now here we don't have a parent because we're starting our search right here. So we pass null. And then we pass our set of visited nodes. Now this will return a Boolean value. If it's true, we're going to return true immediately. We don't need to look at the other nodes in this graph. Otherwise, if we have visited all the nodes and we couldn't find a cycle, we're going to return false. Now here we have too much nesting. We can improve this code by combining these two if statements. So if we haven't visited this node before, and this node has a cycle, then we're going to return true. Like this. That is better. Now let's test our implementation. So back in the main class, here we have 3 nodes and 2 edges, one from A to B and one from B to C. Obviously, there is no cycle, but let's verify that. So print graph has cycle. We get false, beautiful. What if we add an edge from C to A? Now we have a cycle. So this is how we detect a cycle in undirected graphs.